A gas occupies 900 milliliters at 27 degrees Celsius and 1 atm. Wow, that was a short sentence, but it was packed with information. So I'm going to highlight the things that I was given. So 900 mLs, I know that is a volume because it says liters, right? So I'm going to write, this must be the volume originally. I also see 27 degrees Celsius. This must be the temperature originally. And then I have 1.5 atm. I know atm is a pressure, so this must be P1. Before we go too far, I like always converting my Celsius temperature to kelvins as soon as I see it. And so 27 plus 273 is going to be 300 kelvins. Perfect. Now, what happened to this gas? What's going to be the final conditions? What is the volume at STP? What? They didn't even give me more numbers, but this is super important. Remember how this stands for standard temperature and pressure. So even though they didn't really give me a number, I actually have a value that I can use for T1 and for P1, because if they are standard, I can look them up in table A. So I'm going to run there and find my values. I know that the temperature standard is 273. Again, that's from the reference page. And my pressure, oh, I should have put a 2 here. Did you see that was a mistake I made? Huh. So I'm correcting that. So it's T2, P2. T2, if it's standard, must be 273 because that's what table A says. And the pressure, because this is in ATMs, I'm also going to select the pressure in ATMs. I'm not going to select 101.3 kilopascals. I'm going to match the unit. So I'm going to say 1 ATM because I want to keep it, the same, right? I want to make sure that I use the same unit at the beginning and at the end. Okay, so then now I have enough information here. One thing that I noticed this time is that I can't really eliminate anything. Everything changed, so now I'm going to have to deal with the 6 variables. And also I noticed that the volume, V2, is what I don't know. Okay, so P1, where did we find that? 1.5 atm. The volume originally was 900 milliliters. The temperature originally, again in kelvins, is 300 kelvins. Pressure 2, well, I'm going to grab the standard that I got from table A. Is going to be 1 atm. Volume, oh, this is what I don't know. This is what I'm going to be looking for. T2 is going to be standard again, and I'm going to look that up in table A. We did that already, 273 kelvins. Okay, so same idea, it's just a little bit longer because now I have to do all of the variables instead of just 4 of them. Okay, so let's rewrite our formula right here. And I'm going to substitute. P1 is 1.5. Volume 1 was 900 over the original temperature of 300 kelvins. Okay, my second pressure is going to be 1 atm. I don't know the volume, so I'm going to keep it as a variable. And T2 is going to be 273 kelvins. Okay, and if all they want is a numerical setup, this would do it. This could be the end of the problem. But if they wanted you to actually solve this problem, as I've told you before, you can go ahead and do a quick cross multiplying in which you match these terms, cross the equal sign, and let's rewrite that and see what that would look like. I'm going to write this 300 times, I'm going to go around like this, times 1 atm times V2, right? Because that's sitting there, that's my variable, like X. You could write an X if you'd like. So I'm doing the other leg now. I'm barely gonna have space. I'm gonna have to go down like this. All right, get the idea. Now I'm going to get rid of everything that's being multiplied by the b, which is my variable. So I'm gonna divide by 300 and also divide by 1 ATM, which I know is not gonna do much, but I'm writing it just to make sure that we know everything will cancel out. But I gotta do the same thing on the other side to keep my equality, and that is gonna be divide by 300, divide by 1 ATM, right? And then I would have to grab a calculator. Of course, you're grabbing a calculator. You're always allowed a calculator for our tests. And you're going to calculate that. So 1.5 times 900 times 273, then divide by 300. And that results in 1,228.5 watt. Let me see, this was in milliliters, so I'm going to write milliliters as the new volume of this gas.